Alright guys, let's solve another question from the second chapter of Meriam textbook, Statics, and we have four people that are attempting to move a stage platform across the floor. If they exert the horizontal forces shown, we need to determine the equivalent force couple system at point O, and in the B part, the points on X and Y axis through which the line of action of the single resultant force are passes. So if you look at the question, we see that we have X and Y axes here, and basically we need to replace all of these resultants for the B part of the question with one single force that passes through, or the line of action passes through y-axis, and same for the x-axis. So basically we need to find these distances in each of these. So before everything, we are looking for a force couple system about O, and for finding the force, we are looking for the resultant of all these forces. So looking at that, we have forces in x direction and y direction, so that's going to be our vector form of the resultant. So Rx would be basically the sum of all forces in x direction. We have the 90 pounds, we have 80 pounds, they're both to the right, so positive 90 plus 80. And we also have the x component of 70 pounds, so if you resolve it, it's going to be two components, and 70 cosine of 45 degrees is going to be the x component. So that's pretty much everything for Rx. Let's see what we get. So 90 plus 80, 170 plus 70 cosine of 45. So 219 pounds for Rx, and for Ry, we have sum of all forces in y direction. We have the y component of 70 pounds. So 70 sine of 45 degrees positive, and we also have the 37 pounds upward. So let's see what we get for this. 35 plus 70 sine of 45, and this is going to give us 84.5 pounds. So now we figured our R, so basically 219I plus 84.5 J, and the unit will be in pounds. So the force couple system, the force part is done, and now we have to figure the couple out about point O. So we are looking for sum of all moments about O, counterclockwise positive. Our sign convention, so the moment of 80 pounds about O is going to be nothing because the R, or distance vector, is 0. We have the 90 pounds, which makes a clockwise moment, so negative 90 times the distance would be the vertical distance from O to the line of action, which is 66 inches. We have the moment of 35. This one, as we can see, about O is going to make a counterclockwise moment, so plus 35 vertical distance from O to the line of action. This is going to be 88. And we have the moment of 70 pounds, so we're going to go with the moment of X and Y component. Let's do the X first. So the moment of X is clockwise, so negative. We figured the force is 70 cosine of 45 degrees. And the good thing about the angle of 45 is that the value of the sine and cosine is the same, so it really doesn't matter if you mess up with the angle. So same distance from O to the line of action, again 66. And we have the moment of Y component. This one's counterclockwise, so plus 70. This one's sine of 45 degrees, and the distance would be 88. So let's just calculate this. So negative 90 times 66 plus 35 times 88, negative 700 cosine of 45 times 66 plus 70 sine of 45 times. So yeah, that's gonna give us negative 1771 pound inch, and the negative sign in here shows that the moment is clockwise, and this is going to be the couple. So we found the force couple system about point O, and as we can see, our R is going to be in this direction. So basically we have to find the R where the line of action either crosses the Y or X, so we can replace it either here or here. And we are asked to find these distances. Let me just clean up the figures. Too busy. All right, so let's start with this point or see what distance it makes with y. So we can use the 2D shortcut again, the x component and y component of the r. We can see, so this is ry, rx. You can see that ry is not gonna make any moment, so we have the moment of rx, which is 290. So the moment about o, we figured is 70, 71, and negative. So the moment of rx is gonna be also clockwise, so negative rx, which is 219 times the vertical distance is y. So this is the y, 1771 divided by 219. 8.09 inches, and I'm gonna show different color for x. Same idea, the rx won't make any moment. We have the moment of ry. And since the moment is clockwise, so our r has to be in different direction because the moment needs to be clockwise. So our ry is going to be, it's not something like this, going to pass through here. So the rx is in this direction, and that's going to be make a clockwise moment. Ry is 84.5. So we need same moment, 1771 negative. This time the rx is 84.5, and we can find the distance x. Let's see what we get. 1771 divided by 84.5. So the x is going to be 21 inches. And yeah, if you want to replace these with one single force, this is going to be the r that passes through y-axis, and this is going to be the r that passes through x-axis. Again, same r, is just a different rotation and different direction in order to make the moment about point O. Hope everything is clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.